Hello, pre-algebra students. We're at chapter 9.5, the distance and midpoint formula. So we're going to use the Pythagorean theorem to help us find distance, midpoint, and slope formulas. Let's get started. Let's begin our discussion of the distance formula by taking a look at this graph of a right triangle. If we wanted to find the distance between points A and C, that's a fairly simple calculation. The distance between point A and C is simply the absolute value of the difference of the x-coordinates. So we would calculate that by simply finding the absolute value of the difference between the two x-coordinates, which would give us a length of 7. If we wanted to find the distance between point B and point C, which is on a vertical line, we would once again find the absolute value of the difference in the y-coordinates. So again, here we would say that BC is equal to the absolute value of 6 minus 2, which is equal to the absolute value of 4, which is equal to simply 4. So now we know that this distance is 4 and that this distance is 7. But what if we want to find the length of line AB? That's a little trickier because that is a hypotenuse. It's not just a straight line, straight vertical line, or a straight horizontal line. So we're going to have to use the Pythagorean theorem to solve for that. Let's get a clean screen to figure that out. Now we can solve for AB with our clean screen here. So our Pythagorean theorem tells us that AB squared equals AC squared plus BC squared. So AB then is going to equal the square root of AC plus BC. We know what AC and BC are. We solved for those on the previous screen. That would give us 7 squared plus 4 squared, correct? Those were our lengths of our lines. So we now have the square root of 65 being the length of our hypotenuse. So this example suggests that a formula does exist for finding the distance between any two points in a plane shape. We call this the distance formula. In words, the distance formula is defined as this. The distance between 2 points in a coordinate plane is equal to the square root of the sum of the horizontal change squared and the vertical change squared. In algebra form, we'd write that as d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. This is exactly what we did in our previous example problem. We first found that the horizontal change, or the length of line AC, was 7, and that would have been our x right here. We then found the vertical change, and that was 4. Remember, the line BC was a length of 4, and that would have been our y2 minus y1 to get that 4. Then we simply used the Pythagorean theorem. Remember, we squared 7, and we squared 4. We added it together to get that square root of 65 as our distance. Let's work an example using just the formula. So we want to find the distance between points M, which is at 6, 3, and N, which is at 5, 7. So let's plug our numbers into the formula and find that distance. So our first step is to substitute our number values in for the x's and y's in the formula. So M will be our x1 and our y1, and N will give us our x2 and our y2. So let's simply start by making some substitutions here. So x2 is 5 and x1 is 6. That's going to be squared, plus y2, which is 7, minus y1, which is 3. That is again going to be squared. It all goes under the radical. Remember, we're going to find that square root. So now let's do these calculations. So we're going to have -1 squared plus 4 squared, all under the radical sign. So that gives us 1 plus 16 under the radical sign, which gives us the square root of 17 as our answer. So the distance between points M and N is the square root of 17 units. And here is your first checkpoint for this chapter. Please find the distance between each of these pairs of points. Just to help you out, let me give you that distance formula again. There you go. Please press pause while you solve these 3 problems. And next, we're going to use the distance formula for a real-world problem. Let's solve that real-world problem. This is about bird watching. So a bird watcher uses a grid to photograph and record the locations of birds feeding on the ground. So that grid is pictured here. The grid is made of fishing net with strands that are 1 foot apart. In the grid shown, each point represents the location of a bird. So we have a bird at A, B, C, D, and then we have 1 unlabeled point as well. How far apart are the birds at points A and B? Well, to solve that, since it's not a vertical or a horizontal line, we're going to use the distance formula. Here it is again. All right, there's that handy distance formula. So our first step is to find the coordinates of point A and point B, since we want to know how far apart our birds are on this line. Okay, so the coordinates of point A are 3, 2, and the coordinates of point B are 7, 5. Okay, so let's plug these into our formula, using A as x1 and y1 and B as x2 and y2. So here we go. So we have 7 minus 3 squared plus 2 minus 5 squared. And all of that goes under a radical sign, so remember to get the square root. So simplifying that, we have 4 squared plus -3 squared. I'm going to go this way so we have space, guys, which gives us 16 plus 9, or the square root of 25, which is equal to 5. So the birds at points A and point B are 5 feet apart. And here's your next checkpoint. Using the same grid, calculate how far apart the birds at points C and D are. Press pause while you work. Now let's move on to the midpoint formula. The midpoint formula is going to help you find the point that is equally distant from the end point of any line segment. So the words for this formula are: the coordinates of the midpoint of a segment are the average of the endpoint's x coordinates and the average of the endpoint's y coordinates. The algebra formula for that is m, the midpoint, equals x1 plus x2 divided by 2. That's going to be the average of the x coordinates. And then y1 plus y2 divided by 2, which is the average of the endpoint's y coordinates. Let's try using this with a pair of coordinates. Let's find the midpoint M of the segment with endpoints 3, 8 and -9, -4. Let me drop in that formula for us to use. And now let's begin by substituting in some of our values. So 3, 8 will be our x1 and y1, and -9, -4 will be our x2 and y2. So here we go. M equals x1, which is 3, plus x2, which is -9, divided by 2. And then we have y1, which is 8, plus y2, which is -4, divided by 2. So now we begin simplifying. 3 plus -9 divided by 2 gives us a value of -3. 8 plus -4 divided by 2 gives us a value of 2. So our midpoint is -3, 2. Here's a neat trick for finding slope as well. So if points A and B don't lie on a vertical line, you can use coordinate notation to write a formula for the slope of the line. It's pretty cool. Watch this. So if A is x1, y1, and B is x2, y2, we're simply going to calculate slope by finding the difference of the y coordinates, so y2 minus y1, and we'll put that over the difference in the x coordinates, x2 minus x1. Pretty slick, huh? Let's use this for an example problem. So let's find the slope of the line that travels through 3, 7, and 8, negative 3. So as a reminder, our slope formula is y2 minus y1 divided by x2 minus x1. So let's simply begin by substituting. So y2 is negative 3, y1 is negative 7. We'll place that over x2, which is 8, minus x1, which is 3. This gives us negative 10 over 5, which simplifies to negative 2. So your slope is negative 2. Here are your final checkpoint problems for this section. In the first problem, problem number 5, find the midpoint for a line segment with the endpoints negative 7, 1 and 5, 11. For problem 6, find the slope of the line that travels through 2, 7 and negative 3, 5. I'll see you tomorrow for some more practice.